Okay, so for this video, we're going to be looking at proving lines are parallel. So given this diagram, I want to determine which lines, if any, must be parallel and explain your reasoning. So we want to use our theorems that we've learned in the previous videos. And so I know that one theorem I have is lines perpendicular to a transversal theorem. And that one says that if two lines are perpendicular to the same line, then they are parallel. So I see I have a couple of different lines perpendicular to a line, because I know from these right angles. So the first thing I notice is that S is perpendicular to R. I also see that T is perpendicular to R. So since S and T are both perpendicular to my line R, that means that they're parallel. So I know that S is parallel to T. And now I also have another pair that are parallel. I see that I have that these two lines are also perpendicular to S. So I see that P is perpendicular to S. And then I also see that R is perpendicular to S. Now since lines P and R are perpendicular to S, that means that P is parallel to R. And so that's going to be, both are true by lines perpendicular to transversal theorem. Let's look at another one. We use a diagram to answer the following. So is B perpendicular to A? Explain your reasoning. Or sorry, is B parallel to A? So I want to see if B is parallel to A. Well, again, just going based off of that previous example, I know that they're going to be parallel if they're both perpendicular to the same line. Well, I noticed that A is perpendicular to C, but B, I don't know if it's perpendicular to C. But also, A is perpendicular to D, and then I see that B is also perpendicular to D, and I know that from these right angles that we see right here and here. So, since they're both perpendicular to the same line, by the lines perpendicular to transversal theorem, this is going to be yes. I'm going to say yes by lines perpendicular to transversal theorem. Okay, now I need to determine if B is perpendicular to C. So I first know that A is parallel to B. Or B is parallel to A. We just shown that. So I'm going to go ahead and draw those in. I don't know if B is perpendicular to C at the moment because I don't have any markings for it. However, I do know that A is parallel to B, and I know that A is perpendicular to C. So I know A is parallel to B. And A is perpendicular to C. So that means that B is perpendicular to C, and why is that the case? Well, that's the case by the perpendicular transversal theorem. So we go back to that. That one says if a transversal is perpendicular to one of two parallel lines, then is perpendicular to the other line. And so that's how we know that B is therefore perpendicular to C. And then last thing is we have another term that we're going to learn about and we'll practice with more is the perpendicular bisector. And that says that a line is perpendicular to a segment at the segment's midpoint. So perpendicular segment, or perpendicular bisector is just a line perpendicular to a segment at the segment's midpoint. And so we see that here, line N is perpendicular to PQ. And we see that it's cutting it in half, and I see that PM is congruent to MQ.